Welcome to the unit on data, or as we refer to it in the algebra curriculum, unit number 5. Specifically, we're going to be talking about quantitative data. What is quantitative data? Quantitative data is information that can be measured or quantified with units. For example, temperature would be considered quantitative data. It may be measured in Celsius units, Fahrenheit, Kelvin scale. The bottom line is temperature can be measured. What else could be measured? The number of students in a class can be measured. And what would the units be? I know that's horrible writing. The units would be students. If there's 10 students in the room, you would say 10 students. Okay. These two examples bring us to the next two vocabulary units. First, there's two types of quantitative data. There's continuous and discrete data. What is continuous data? Information that can be measured on a continuum or scale can have almost any numerical value. It's sort of referenced as, an infinite set of numbers or uncountably many numbers. Temperature. Sorry about that abrupt distraction. Temperature is continuous. If you woke up in the morning and it was 5 degrees out, Fahrenheit, and then later on in the day it went up to a balmy 20 degrees, did it jump from 5 degrees straight to 20, or did it pass through every possible value in between 5 and 20? And the answer to that is it passed through all of them, uncountably many degrees in between. Okay, so that's an example of continuous. Therefore, number of students in a room will be discrete. What is discrete more specifically? Information that can be categorized into a classification based on counts, and it's finite or countable. So the number of students in a room, right, is finite. You can count how many students there are. There's 3 students, you take 1 out, there's 2 students. There wasn't anything at any given point that there was 2.5 students. Even if you had a kid come in with no arms and no legs, that is 1 full student, okay? And I'm not trying to make a joke about that. I'm just saying that there's no half unit in this situation. Number of televisions, something like that in your house. Again, discrete information. Your height would be continuous. Your weight, continuous. I think there's about enough examples. Now, the types of displays that we could use to display quantitative data, right? Graphical displays, histograms, that's where we're going to focus our attention in this video, box plots in a later video, and scatter plots. And scatter plots are for bivariate data. So you generally have 2 variables. Box plots and histograms will focus on 1 variable per picture. All right, let's move on. Histograms. What do they look like and how do you build them? In the simplest terms, a histogram is a diagram of rectangles, right, down here, whose area is proportional. This area is proportional to the frequency of the variable that it refers to. It'll make more sense in another slide. Just get this down into your notes. Each column has a lower bound, so right on this end, this is the lower value and this is the upper value. This lower value, say this lower value was, say, 16. If you had a value of 16, it would go in here. If the upper value was 17, 17 would go here. So the lower bound is inclusive. Any number that matches that one goes in that bar. The upper bound number, 17, is exclusive. Any value that matches this one goes in the next bar. Again, it'll make sense in a few. Okay, so now let's just get into the crux of it, shall we? What we have here is a list of home run hitters, and the following table lists American League and National League top 20 home run leaders. Now, what you should have out in front of you while you watch this is the handout from your teacher. Now, this is only, forgive me of my baseball knowledge, is just the American Leaguers. You have the National League on the other side of your paper. So I'm just going to focus on the American League. From the number 1 most home runs, 43 in a season, down to the 20th for the American League, just 26 home runs. So first, let's talk about the mean. How do you get to the mean? we're going to call this X bar. And X bar stands for sample mean, and the formula for the mean, as you know, is to add up all of these values. So symbolically, we're going to use the Greek letter sigma. Sigma means to add up. So we're going to add up all of our x's, how many of them there are, and we're going to call that x sub n, right? So 43 is x sub 1, 41 is x sub 2, so on and so forth down to 26 is x sub 26. So in this case, n is 26. So we're going to add up all of the x's, and we're going to divide them by the number of items that there are. You know how to get the mean. You add up all of the values and divide by 20. Then the median, we want all of these values to be in order, and they are from the top to the bottom. So in order to get the median, what we're going to do is just start crossing off. 43, we'll cross off the ends, and cross off the ends again, and keep crossing off the ends until we get to the center. Now what happens is we're left with 30 and 30 in the middle. And so if we cross those two off, we'll have nothing. So since this is an even numbered set, the median is going to be the average, right, the x bar of the two middle values. Well, 30 plus 30 is 60, divided by 2 is back to 30. So that's going to be 30. The mode is the most used. 29 showed up 4 times, so 29 is our mode. I don't really focus on the mode too much, but it seems to be a popular value. The minimum, obviously, the smallest number in the value in the number set is 26. The maximum is 43, and the range is always going to be, right? It's a distance, your max minus the minimum. So we just need to calculate by hand here really quickly, the mean and the range. So go ahead, press pause and do that. I just cleaned up my screen a little bit, and here's what I have. 31.6 for the mean, 30 for the median, 29 for the mode, 26 for the minimum, 43 for the maximum. 43 minus 26 is going to equal 17. There was n equals 20 players, right, the number of items that we have, and our units is home runs. So all of the units on this, remember, this is quantitative data, so number of home runs is discrete, right? This is discrete data, countably many. You can't have anything less than one home run, right? So it's 26. Then the next number of home runs you can have is 27. It's not like there's a value 26.5 home runs, not possible. So all of the values here are home runs. 29 is the mode, 29 home runs. 17 is the range, 17 home runs. There's a 17 home run difference between the largest value and the smallest value. Okay, let's move on. Now this next portion of the game, what we're doing is we're setting up to construct our histogram. So we're going to make a frequency table for the number of home runs in each game. And just like I said, that lower bound and upper bound in our bar of the histogram is inclusive or exclusive. Notice right here, we have the less than or equal to. So for the first interval, it's going to be the number of home runs that is either equal to 20, right, greater than or equal to 20, but less than 24. So who is that? That's going to be 20, 21, 22, 23. Any of those number of home runs we're going to count. And so we just want to see how many times that happens. Now, seeing that the minimum was 26, the frequency for 20 to 24 is going to be 0. It happened none times. How about somewhere between 24 up to, but not including 28? We got 26, 27, 27. 28 is there, but we don't, it's got to be less than 28, so there are 3 values there. Why don't you go ahead, press pause, and see if you can fill in the rest of your frequency chart. Remember, when we add all of these values up, it should add up to be 20. Press pause now and try it out. All right, so this is what I get. I get 0, 3, 10, 3, 2, and 2, and that adds up to be 20, so check. I should be error-free here. So what the handout is asking us to do now is to use this frequency table to make a histogram for each league. So again, let's just focus on the American League and look at our first interval. It's from 20 to 24. So 20 starts, 20 starts here and is going to go to approximately just under 25. So that's how wide each bin is going to be, right? So a bin is the bar width in that histogram. So what I want to do is just go ahead and just make little indications of where the bins start and stop. So I have over here on the chart, I have 1, 2, 3, 4, 5, 6 bins, and right here I have 1, 2, 3, 4, 5, 6 bins. Now they're not perfect. My stylus has a little bit of a limitation on this screen. And now what I want to do is I want to go up to the proper frequency that corresponds to right here. So for my first bin, the 20 to 24, there's nothing in there, so really that bin just doesn't exist. The next one's going to go up to 3. So all I want to do is just extend this up to 3, over and down. And then my next one goes up to 10, right? That's pretty tall, so this is going to go all the way up to 10, over and down, and then so on and so forth. So go ahead and wrap yours up. And so now what I have is a picture, and remember, a picture's worth 1,000 words. This is my histogram, and we can see that the most common amount of home runs was in this bin width where we saw 10 items. Maybe yellow isn't the best color. Right here, this is our most popular bin width, and of course, it's this one right here, the really tall one. Then we have 2 that were 3 apiece, and 2 that were 2 apiece. All right. What we really want to make sure that happens is that we want to draw these bins to be equal width. All right. It was all about being proportional. So 10 out of 20, right? If we look at that bin width, 10 out of 20 of the frequencies with respect to frequency, or that's 50% was in this particular band or bin width. This bar should occupy 50% of the overall area of the histogram. So as long as your bin widths are all nicely spaced, right, equal width, and your frequency is accurate, that proportion or area should work out to be fairly simple. The last thing I want to point out here too is notice that the increments that we went across the bottom were by tens, and then I just negotiated the bin upper and lower bounds to, you know, an approximate location. Have the numbers work for you. Don't work for the numbers. What I'm trying to say is don't use bin widths of 2.7 because you have data that involves decimals. Use simple numbers for your x values, and then just ballpark where those bins need to start and stop. So in wrapping this up, let's just take a quick look at what just happened. We learned about quantitative data and the 2 types that there are. Remember, the discrete and continuous. We also discussed graphical displays. We focused on histograms, but soon to come, box plots and scatter plots. Lastly, we talked about histograms, focusing on, the construction of the histogram, first by focusing on creating intervals, and then transferring those intervals to a nice proportional drawing where we carefully watched the width of our bins and making sure that we matched up nice and neatly to the frequency on the vertical scale. That's about it for this video. See you next class.